Hi student, I will explain about limit. So you can see here the notation of limit is equal to limit x approaches to a of fx. Fx actually refer to any function. So here we have a theorem. Theorem 1, if fx is a polynomial, mean if we have linear, quadratic, cubic or x power of 4 and so on, then limit x approaches to a of fx equal to fa, means we just substitute the value of a into fx. Okay, for example, if we have limit x approaches to 1 of fx, where this fx actually equal to x plus 1. So how to solve this limit? Equal to limit x approaches to 1 and then substitute fx equal to x plus 1, and then next we substitute the value of x equal to 1 into x plus 1 and the final answer is equal to 2. Okay, next we have theorem number 2. Okay, number 1, if we have limit x approaches to a and then we have two function fx plus gx. So we can separate this limit, we get two limit. Limit x approaches to a of fx plus with limit x approaches to a of gx. We can separate these two limit. Or if we have negative sign, so we just put here negative. Okay, number 2, if we have limit x approaches to a and then we have c time fx. C refer to constant. So what we can do, we can bring the constant to the front time with limit x approaches to a fx. For example, we have limit x approaches to 1, 2x squared. 2 refer to constant. So we can apply this theorem. You bring 2 into the front time with limit x approaches to 1, x squared, and then substitute x equal to 1 into x squared. So the final answer is equal to 2. Or another solution or method, we actually just substitute x equal to 1 into this function. So we get the final answer is equal to 2. And number 3, if we have limit x approaches to a fx times gx, we can separate these two limit. We get limit x approaches to a of fx times limit with x approaches to a of gx. Okay, for example, we have limit x approaches to 1. We have function x times e power of x. So we can separate this limit. We get limit x approaches to 1 of x times limit x approaches to 1 of e power of x. And then we substitute one by one. For the first limit, we get 1 times. For the second limit, e power of 1 equal to e. So the final answer equal to e. And lastly, we have limit x approaches to a fx over gx. We have fraction here. So if we separate the limit, we get limit x approaches to a fx divided by limit x approaches to a gx. So for example, we have limit x approaches to 2, x plus 1 over x squared plus 1 equal to limit x approaches to 2, x plus 1 over limit x approaches to 2, x squared plus 2. And then we substitute one by one. At numerator, we get 2 plus 1. Denominator, 2 squared plus 1. So final answer equal to 3 over 5.